Hi everyone. We're going to continue our lesson on properties of logarithms. As I go through these examples, you guys have the option to just watch the video the whole way through, or try practicing these examples on your own and then listening to my explanation of things. Okay, so directions for the first set of examples ask us to use the properties of logs to find the exact value of each expression. For number one, we have the log base 4 of 4 cubed. So there are two ways that you can approach this. Number one is to use, I can't remember if it's property 3 or property 4, where because we have the log base 4 of an exponent with base 4, the log base 4 and exponent of base 4 cancel one another out because those are inverse functions, and you get that log expression to be equal to 3. The other approach that you can take is to take the exponent, pull it out front as a factor, which gives you 3 times the log base 4 of 4. And then using property, I believe it was number 2, because the log base matches the argument, the value of that log is 1, so you get 3 times 1, which is equal to 3. For number 2, again, that's using property 3 or 4. You have 3 raised to the log base 3 of 6 power, 3 raised to the log base 3 of 6 power. Again, the exponential base 3 and the log base 3 cancel one another out because those are inverse functions. So the value of that expression winds up being equal to 6. For number 3, because we are adding 2 logs that share the same base, we can combine that into a single log by multiplying the arguments. So that would become the log base 12 of 4 times 3, which is equal to the log base 12 of 12. And the log base 12 of 12 has a numeric value of 1. Similarly, for number 4, we are subtracting the log base 6 of 24, and we're going to subtract the log base 6 of 4. So if we're subtracting 2 logs that share the same base, we can combine into a single log by dividing their arguments. So 24 divided by 4 winds up being 6. And the log base 6 of 6, once again, is equal to 1. Okay, so on to the next set of examples. So directions here say to suppose that a is equal to the natural log of 4 and b is equal to the natural log of 5. Then we're asked to use the properties of logs to write each log in terms of a and b. Okay, so our goal with these log expressions is to get them written in terms of the natural log of 4 and the natural log of 5. All right, so when we do number 1 here, the natural log of 20, we can rewrite the natural log of 20 as the natural log of 4 times 5. And then because we're taking the natural log of a product, we can separate that into the sum of the natural log of each factor. So that's going to be the natural log of 4 plus the natural log of 5, and then we can replace the natural log of 4 with a and the natural log of 5 with b. Okay, for number 2, the natural log of 4 over 5, because we're taking the natural log of a quotient, I can take the natural log of the numerator and subtract the natural log of the denominator. So that becomes the natural log of 4 minus the natural log of 5. The natural log of 4 is a minus the natural log of 5 is b. For number 3, we have the natural log of 1.25. Well, if we think about 1.25 written as a fraction, that would be 5 over 4. And then we can use the same property as we did with number 2. That's going to be the natural log of the numerator, 5, minus the natural log of the denominator, 4. Again, the natural log of 5 is b, minus the natural log of 4 is a. For number 4, we have the natural log of 1/4. You have two ways that you can approach number 4. The first way is because we're taking the natural log of a quotient. Once again, I can rewrite this as the natural log of 1 minus the natural log of 4. The natural log of 1 is equal to 0 minus the natural log of 4, which we said was a, and 0 minus a is equivalent to negative a. The second way that we can do number 4 is we can rewrite 1 over 4 as the natural log of 4 raised to the negative 1 power. And then we can take that exponent negative 1 and pull it out front as a factor. So that is equivalent to saying negative the natural log of 4. And once again, the natural log of 4 is a, so that's equivalent to negative a. With number 5, the natural log of 25, once again, you have two ways that you can approach that one. So 25 is 5 times 5. So because we're taking the natural log of a product, we can separate that into the natural log of the first factor plus the natural log of the second factor. The natural log of 5 is b, so this becomes b plus b. Excuse me, which makes that expression equal to 2b. Our second way that we can approach number 5 is we can rewrite 25 as 5 to the second power, and then we can pull the exponent out front, so that becomes 2 times the natural log of 5, which is also equal to 2b. All right, for number 6, we have the natural log of the cube root of 20. So I can rewrite this log expression here as the natural log of 4 times 5, and then taking the cube root of that is like raising that to the 1/3 power. So I'm going to take the exponent 1/3 and pull it out front as a factor. And then for me to take the natural log of 4 times 5, again, I'm going to use my log properties to split that as the natural log of the first factor 4 plus the natural log of the second factor 5. Okay, and again, the natural log of 4 is a, the natural log of 5 is b, so that's 1/3 the quantity a plus b. If you want to distribute 1/3 across both terms, that's fine, but it's not necessary for you to do that. Okay, so we're going to move on to the next set of examples. So I think these are like more specialized examples of using log properties, because you have to use some like special techniques in order to evaluate this. So the directions here ask us to find the exact value of the expression, and for number 1, we have the log base 5 of 64 times the log base 4 of 5. So hopefully you can look at both of these log expressions here and be able to get like an approximate value for each one, but also realize, hey, I can't determine the exact value of either of these two expressions. When we look at the log base 5 of 64, like if we're trying to get a numeric value for that, we would think to ourselves like 5 raised to what power is 64? Now, we know that 5 squared is 25, and 5 cubed is 125. So we know like our x value has to be some numeric value between 2 and 3. Excuse me, but we don't know exactly what that numeric value is. Similarly, when we look at the log base 4 of 5, we know that 4 raised to some power needs to be equal to 5. So we know that the log base 4 of 5 is going to be somewhere between 1 and 2, because 4 to the first power is 4, 4 squared is 16, and 5 is somewhere between 4 and 16. So we know we're taking like some number between 2 and 3 and multiplying it by some number between 1 and 2, but we don't know what either of those two numbers are. Okay, so what we want to do to find the exact value of this expression here is when I look at both of those log statements, both of those logarithms do not share the same base. Okay, so what I want to do is I want to rewrite one or both of the log expressions where they share the same base. And usually to do that, what you want to do is to rewrite the larger log base in terms of the smaller log base. So we're going to use the change of base formula, which was property number 10 that we looked at in class last week. And I want to rewrite the log base 5, that's our larger log base, in terms of the smaller log base, the log base 4. So to do that, I can rewrite the log base 5 of 64 as the log base 4 of the original argument, 64. And we're going to divide that by the log base 4 of the original base 5. Okay, so when I use the change of base formula, I see that now I can cancel this factor of the log base 4 of 5 in the denominator with that factor of the log base 4 of 5 in the numerator. So this winds up becoming the log base 4 of 64. So you can figure out the value of that a couple of different ways. Number one, if we think 4 raised to what power is 64, we know 4 raised to the third power is 64. So that's the exact value of that log. Another way for you to simplify this is you can rewrite 64 as 4 cubed. And we know that the log base 4 of 4 cubed is going to be equal to 3 as well. Okay, so when we move on to number 2, for number 2 we have e raised to the power of the log base e squared of 49. Now, this example here, I think most closely resembles property number 3, okay, where we have an exponent raised to a log power. The problem that we have with this is that the base of our exponent is e, and the base of our log is e squared, and they don't match right now. So we can't cancel the exponential function and the log function because they do not share the same base. Okay, so what I can do with simplifying this one is I can rewrite the argument of the log 49 as 7 raised to the second power. When I do that, I can then take that exponent and pull it out front of the log as a factor. Okay, so that's going to give me then e raised to the power of 2 times the log base e squared of 7. Okay, so when we look at this exponent here, oops. So when I look at this exponent, it should be pretty clear that we are multiplying 2 times the log base e squared of 7. And we should know from our rules involving exponents that we multiply exponents when we have a power raised to a power. So what I can do is I can take that line and rewrite it as e squared raised to the power of the log base e squared of 7. Right? That line and the line above it are equivalent, again, because when we have a power raised to a power, we multiply the exponents. Well, when we rewrite this exponential in this way, we have this exponent base e squared and the log base e squared, where the base of the exponent matches the base of the log. So now we can use property number 3 to, because we're taking the composition of a function and its inverse, we can cancel the exponent base e squared and the log base e squared, just leaving us with the argument of 7. Okay, so the exact value of that expression is equal to 7. Okay, So the next set of examples we're going to look at the directions, excuse me, ask us to expand the log expression and write powers as factors. Okay, so we're going to be given a single logarithm that we're going to use our log properties to expand and write in terms of multiple logarithms. So for number one, we have the natural log of the quantity x minus 4 squared over x squared minus 1. We're raising that result to the 2/3 power. And then the domain of this logarithm is x is greater than 4. And that domain is important to us because that's going to allow us to like pull exponents out front, because again, we need the argument of each log to be positive. So the fact that x is greater than 4, like whenever we break these logs up, we're always going to get a positive argument for each of those individual log expressions. Okay, so what we're going to do here is I want to expand this log out. So the first thing I can do is pull 2/3 out in front of my logarithm. So we get 2/3 times the natural log of, and then what I'm going to do is I'm going to use my log properties to separate this quotient into multiple logarithms. Okay, so we know that when we take the log of a quotient, it's going to be the natural log of the numerator, which is x minus 4 squared, minus the natural log of the denominator, which is x squared minus 1. Okay, but we're not done because we can like use our log properties to manipulate this further. So we have 2/3 times, what I can do now is I can take this exponent here, 2, and pull it out front of that first log as a factor. So that's going to be 2 times the natural log of x minus 4 minus. Now, when we look at this x squared minus 1, like I can factor that expression. That is the difference of two squares. So that is going to factor to x plus 1 times x minus 1. So I can use my log properties to expand out or rewrite that natural log of that product in terms of two natural log expressions. Okay, so that's going to be, because I'm taking the natural log of a product, it's going to be the natural log of the first factor, x plus 1, plus the natural log of the second factor, x minus 1. Okay, so just to finish this off, I have to do two things to simplify. Number one, I have to distribute 2/3 across everything. Okay, so I'm going to take this 2/3 and distribute it across this, and across this. And then I also have to take this minus sign and distribute the negative across these terms as well. Okay, so when I do both of those things, that's going to wind up giving me 4/3 times the natural log of x minus 4 minus 2/3 times the natural log of x plus 1 minus 2/3 times the natural log of x minus 1. Okay, so that is that single log expression, like expanded out completely using our log properties. Okay, so we're going to do the same thing with number 2, except that with number 2, we're going to use our log properties to expand in a single step. Okay, so we're not going to show like the intermediate steps to get to our final answer. Hopefully we get to a point where we're good enough with logarithms where we can work this through in a single step. Okay, so I'm going to kind of walk you through the thought process here. If you guys want to try number 2 on your own just to see how you do with it, and then compare that to mine, go ahead and pause the video and then turn it back on whenever you're done. Okay, so once again, we want to take this single logarithm and expand it into multiple logs. So again, we're taking the natural log of a quotient. So what I want to do is I want to take the natural log of each of the factors in the numerator and add them together. And then we're going to subtract the natural log of each of the factors in the denominator. So when you look at your numerator, how many different factors do we have? Well, we have 3 different factors in the numerator. The first one being 5, the second factor being x squared, and the third factor being the cube root of 1 minus x. Now, a common mistake that I see students make with questions like this is they think of like 5x squared as being a single factor. And I will see students take 2 and pull it out front like this and rewrite it as 2 times the natural log of 5x. That is not correct for us here because that exponent of 2 does not apply to the factor of 5. It only applies to the factor of x. Okay, so you can't pull that exponent out front because it does not apply to both factors in this particular case. Okay, so if we want to rewrite this log here, the first factor in the numerator is 5, so we're going to take the natural log of that first factor, plus, I'm going to leave myself a little bit of space here because I'm going to talk about taking the natural log of the next one. So the natural log of our next factor is x squared. But again, the directions for our problem tell us to express powers as factors. So I can take that exponent of 2 and pull it out front as a factor. So we get the natural log of 5 plus 2 times the natural log of x plus the natural log of the next factor. The cube root of 1 minus x is 1 minus x to the 1/3 power. And then I'm going to take that exponent of 1/3 and pull it out front as a factor as well. So that's plus 1/3 the natural log of 1 minus x. And then because I'm dividing by 4 times x plus 1 squared, I'm going to subtract the natural log of each factor in my denominator. So there are 2 factors in my denominator. The first one is 4. So I'm going to subtract the natural log of 4. And then we're also going to subtract the natural log of x plus 1 squared, which once again, I'm going to take that exponent and pull it out front as a factor. So that's going to be minus 2 times the natural log of x plus 1. Okay, so that right there is your log expanded completely. So just to give you one more to practice. So number 3 is very similar. You have the natural log of the quantity 3 rad x times x plus 2 raised to the 4th power. We're dividing that by 5 times the cube root of x minus 1. Again, the domain for that is x is bigger than 1. Okay, so see if you can expand that in a single step as well. Okay, so when you do that, this is what you should have come up with. You should have gotten the natural log of the first factor, 3, plus the natural log of rad x is like the natural log of x to the 1/2 power. So I can rewrite that as 1/2 the natural log of x, plus the natural log of x plus 2 to the 4th power. Again, when I pull that exponent out front as a factor, that is 4 times the natural log of x plus 2. And then we're going to subtract the natural log of each factor in our denominator. So that's going to be minus the natural log of 5, minus the natural log of the cube root of x minus 1 is x minus 1 to the 1/3 power. So we can pull 1/3 out front as a factor. So it's 1/3 the natural log of x minus 1. Okay, so for the next set of 2 examples, we're going to work through the process in the reverse direction. So these examples here, we're going to have multiple log expressions that we want to condense down into a single logarithm. Okay, so to do that here, we are subtracting 2 logs that share the same base. So we can combine into a single log by dividing their arguments. Okay, so I'm going to do two steps here. I'm going to divide the arguments, combining into a single log, and then I'm going to factor the numerator and denominator of each fraction. Okay, so for x squared plus 2x minus 3, that's going to factor to x plus 3 times x minus 1. For x squared minus 4, that factors to x plus 2 times x minus 2. And then we're going to divide the next fraction, so x squared plus 5x minus 6 factors to x plus 6 times x minus 1 divided by x plus 2. And then if we're dividing two fractions, we can do so by taking the reciprocal of the second and multiplying. So this becomes the common log of x plus 3 times x minus 1 over x plus 2 times x minus 2 times x plus 2 over x plus 6 times x minus 1. And then we can simplify the argument here by canceling factors in the numerator and denominator. So we can eliminate those factors of x plus 2 and these factors of x minus 1. So this becomes the common log of x plus 3 over x minus 2 times x plus 6. Okay, so we're going to do the same thing for number 2. So for number 2, when we look at number 2 has 3 individual log expressions. Okay, so when that's the case, what we're going to do when simplifying is we are going to work from left to right, just taking 2 log expressions at a time. Okay, so what I can do with these factors out front is I can make them the exponents for the log arguments. So this is going to become the log base 5. Because I'm subtracting 2 logs that share the same base, I can combine into a single log by dividing their arguments. So the numerator will be 3x plus 1 cubed. The denominator is going to be 2x minus 1 squared. And then we're going to subtract the log base 5 of x. Okay, so when I take that quotient and when I subtract x, that's the same thing as combining into a single argument and dividing by x. So when I divide by x, that's the same thing as like multiplying that argument by 1 over x. So when I take those 2 log statements, combine into a single log, we get the log base 5 of 3x plus 1 cubed over x times 2x minus 1 squared. Okay, so that's using our log properties to combine that expression with multiple logarithms into an expression with a single logarithm. Okay, so last example here is above and beyond what I would ask you on a test. I've actually given this exact problem as an extra credit question on an honors pre-calc test. So this is like, more difficult than a standard question. I think this one's a really good one to see if you have like a really good understanding of your log properties, and if you are unable to work it through, like it's okay. It's just one to kind of like help push your understanding of these log properties a little bit further. Okay, so the directions here ask you to use the properties of logs to find the exact value of the given expression. And for this example, we are given the log base 3 of the square root of 243 times the square root of 81 times the cube root of 3. And we are dividing that by the log base 2 of the fourth root of 64 plus the natural log of e raised to the negative 10 power. Okay, so I definitely want you to pause the video to try to give this one a try. And then when you think you've worked it through correctly, you can go ahead and turn it back on and check to see how you did. Okay, so what we want to do here is we want to use our log properties to like rewrite each of these individual log expressions. So we have a single log expression in the numerator, and then we have two log expressions in our denominator. Okay, so what I'm going to do is I'm going to take these radicals here, and I'm going to rewrite them with rational exponents, because that's going to allow me to pull those exponents out front as factors. Okay, so up top here we have the log base 3. Now, when I take that biggest radical, that is like taking the entire quantity in the numerator and raising it to the 1/2 power. Okay, now when I see the individual numbers like 243, 81, and 3, what I want to do with each of those numbers is I want to rewrite them, because we're taking the log base 3 of those numbers. I want to try to rewrite those numbers as 3 raised to some numeric power. Okay, so when we look at 243, we know 3 to the first power is 3, 3 squared is 9, 3 cubed is 27, 3 to the fourth power is 81, 3 to the fifth power is 243. So I'm going to rewrite 243 as 3 raised to the fifth power. And then I'm going to take the medium-sized square root. So when we take the square root of 81 times the cube root of 3, I'm going to take that quantity. Again, because we're taking a square root, we're going to raise it to the 1/2 power. And then 81, so again, 3 to the first is 3, 3 squared is 9, 3 cubed is 27, 3 to the fourth power is 81. So I can rewrite 81 as 3 to the fourth power. And then we are multiplying that by the cube root of 3. And the cube root of 3 is 3 raised to the 1/3 power. Okay, so in our denominator, we're going to do the same thing. So we have the log base 2 of the fourth root of 64. I want to try to rewrite that expression, because we're taking the log base 2 as 2 raised to some power. Okay, so the fact that we are taking the fourth root means we're going to like raise our exponent to the 1/4 power. And then 64, so 2 to the first power is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth power is 16, 2 to the fifth power is 32, 2 to the sixth power is 64. So I can rewrite 64 as 2 to the sixth power. Okay, plus the natural log of e raised to the negative 10 power. So again, we're taking the composition of a log base e with an exponential base e. So those wind up canceling one another out. And that is equivalent to negative 10. Okay, so what I'm going to do now is I'm going to take that single log expression in the numerator, and I'm going to use my log properties to expand it and write it in terms of multiple log expressions. Right? So I'm going to take this first exponent of 1/2 and pull it out front as a factor. So we have 1/2 times, and then I'm going to take the log base 3 of the first factor inside of the argument. So that's going to be the log base 3 of 3 to the fifth power. Okay, plus I'm going to take this next exponent of 1/2 and pull it out front of my remaining logs. So we get plus 1/2 times, and then we're going to take the log base 3 of our next factor, which is the log base 3 of 3 to the fourth power, plus the log base 3 of our next factor, which is the log base 3 of 3 to the 1/3 power. Okay, so that is your entire numerator expanded out completely. And then in our denominator, like when we have a power raised to a power, we multiply the exponent. So our first term on bottom, I'm going to rewrite this over here because I just don't want to work out another step. So when we have a power raised to a power, we multiply the exponent. So that's the log base 2 of 2 to the 6/4 power. 6/4 simplifies to 3/2. And the log base 2 of 2 to the 3/2 power is going to wind up becoming 3/2 minus 10. Okay, so let's start simplifying what we have in the numerator here. So we have 1/2 times the log base 3 of 3 to the 5th power is going to be 5. Excuse me, plus 1/2 times the log base 3 of 3 to the 4th power is going to be 4, plus the log base 3 of 3 to the 1/3 power is 1/3. And then we're going to divide that by 3/2 minus 10. So that's 3/2 minus 20/2. That's going to wind up being negative 17/2. Okay, so let's simplify our numerator. So we have 1/2 times 5 plus 1/2 times 4 plus 1/3. That's going to wind up being 13/3 over negative 17/2. So we get 1/2 times 5 plus 13/6 all over negative 17/2. So 5 plus 13/6 is 43/6. Okay, times 1/2 is going to make 43/12 over negative 17/2. And then if I want to simplify this, I can multiply the numerator and denominator by the common denominator of the smaller fractions, which is 12. So 12 will cancel with that 12. 2 goes into 12 6 times. So this winds up becoming negative 43 over 17 times 6, which is 102. So it's negative 43 over 102 for the value of that log expression. All right, so hopefully some of you were able to work that out correctly. If not, hopefully after seeing me work it out, you're able to understand and perhaps work through a similar question in the future. Okay, so that's going to be it for this lesson. I hope you guys have a great rest of your day. Take care.